So what I'm going to talk about now is getting a little into more details on generative AI and vector store processing. So it's going to be covering a lot of the content which Wim talked about, but I'll be hopefully covering it in a little more detail and also highlighting some of the use cases we have seen for generative AI and vector store. So just to recap about MySQL HeatWave, right? So MySQL HeatWave is a fully managed data service from Oracle. It is designed, so HeatWave has been designed to process data in a scale-out manner. So it's been designed to process data which resides in the object store. And when I say process data, it means it can run analytics, it can run machine learning, and now we're extending that capability to provide support for generative AI in vector store. But even the way it is right now, HeatWave is the most scalable database. A single instance of HeatWave can span 512 servers. And the reason we built this scale-out system is because we see that there is more and more data coming into Lakehouse, into data lakes. So when you have hundreds of terabytes of data or petabytes of data, you want the ability to read the data efficiently, process the data efficiently, and write the data back to the object store very efficiently. And the reason object store is very interesting is because object store provides the least expensive form of storage. So if you have some amount of data and you want to park the data somewhere, object store is the least expensive and the most durable form of storage. And the reason HeatWave is a very interesting combination is because HeatWave runs on commodity gear and it's extremely inexpensive. So you can keep your data in the object store for as long as you want, only pay the object store prices. And when the time comes for you to run analytics, you can just spin up an instance of HeatWave, do the processing. When the time comes when you want to run machine learning, same thing, like you have your data in the object store, and when the time comes for machine learning, you spin up an instance of HeatWave, and you can do that. This is one of the reasons that many of the telcos are very interested in this capability, because telcos have these CDR records, which for the most part are not queried very often, and they are typically hundreds of terabytes of data. So telcos love MySQL HeatWave because they want to keep the data in the object store in a reliable manner, in a less expensive manner. But when the need comes, they can query it and query it very efficiently with HeatWave. HeatWave also processes data if the data is transactional, in which case it is stored inside the MySQL database, right? So if your data is transactional in nature, you got to store it in MySQL database. But for everything else, object store is a very good choice. The second thing to note, right, is that when we are processing data in the object store, we are not coming up with our own new syntax to access this data. We are providing the same syntax. We use the same syntax, the same semantics of the MySQL database. And the reason is MySQL is the most popular open source database in the world. So if your data is in the MySQL database, there are millions of tools and applications which have been written on MySQL. Now, all of those tools and applications can work without, say, much modification for data in the object store, right? So that's why with MySQL HeatWave, we see a lot of popularity, obviously with customers who use MySQL, because MySQL was designed for transactional processing, but now we're extending it for analytics, for machine learning, autopilot, right? But it is also very attractive for customers who have the data in the object store. Now, there are 4 new capabilities which we are introducing as a part of generative AI and vector store processing. The first is the vector store. Vector store provides the capability where data which is unstructured in nature can be queried, right? So in the past, both with MySQL and HeatWave, you could query structured data or you could query semi-structured data expressed as JSON. With vector store, we now provide the capability of querying unstructured data, like unstructured text, like PDF, PPT, Word, right? The second aspect is the vector processing. What vector processing allows you to do is to query this data not just as an exact match, but to do semantic match, or what is also referred to as similarity search, right? So if you want to say that is this image similar to some other image, right? This notion of similarity, or is this audio similar to this other audio clip? This notion of similarity is enabled by vector processing, right? So the first part is the vector store, where you basically take unstructured data and transform it to a point in an n-dimensional space. The second aspect is being able to process this data or query this point in space, and that's a semantic aspect to it. The third is generative AI, right? So generative AI, I'm sure most of you have heard about it, but in the context of MySQL HeatWave, this combination of generative AI and vector store provides the capabilities of LLMs to your enterprise content. Like as Sandeep was showing in the previous demo, without vector store, the LLMs are trained on public content, right? So they're going to give you some stuff, but for enterprise content, those results may be, almost gibberish. But with vector store and generative AI, we are bringing the power of LLMs to your enterprise content. The second distinction about generative AI is that unlike machine learning, generative AI can generate new content, right? So for instance, summarization is a very good example, and we'll talk about more use cases, but generative AI provides a lot more capabilities, and now those capabilities are now enabled for enterprise content. And finally, we're integrating all of this with a very nice graphical user interface, which provides two things. We call it HeatWave Chat, but it provides two things. First, the ability to navigate your data in the object store, right? So if you have data in the object store in a variety of files and folders, you can now, using this interface, navigate this. And secondly, you can now query this data. You can query this data obviously in SQL, but you can also query this unstructured text data in natural language. And for now, we are starting off with English, but I'm hoping over time we will add other languages as well. There are three new use cases which I'm going to talk about, which are enabled with generative AI and MySQL HeatWave. The first one is content generation and summarization, right? So one of the things I talked about, I was mentioning, is that with generative AI, look, when you do query processing or when you do machine learning, typically the output is a subset of the data which is in there, right? So if you want to say, hey, give me the list of the people who work from this office, the result which is returned is a subset of the data inside the database. Similarly, with machine learning, it can make some predictions, right? But the cool thing about generative AI is that it can generate new content. And a very good use case of that is summarization. So there are customers we have who have a document and they want a synopsis of it. They could be, like many of these documents have a lot of legal jargon, and just you want to know, okay, what's the basic abstract, right? So summarization is a very good use case of content generation in the context of enterprises. That's the first use case we're going to talk about. The second one is RAG, right? So RAG is the one which I was saying, okay, it's basically giving you the power of LLMs for your enterprise content, right? And the way this thing works is that you generate a vector for your unstructured data, keep it inside the database, and when the time comes, you can query this and then feed this into the LLM, right? So it's providing the power of LLMs for unstructured data inside the database. And the third is the ability to interact with the database. And for now, we are saying, okay, with unstructured text data in natural language. And this is really, really important because it's not just for fun that, hey, you're trying to test the system, is it going to work or not? But in a lot of the large enterprises, they aren't like domain experts, or they aren't people who understand databases, or they aren't like divisions who can translate what the expert wants into the SQL which is required to query. So having a natural language provides a lot of the executives, a lot of the domain experts to be able to get value from this data, which is otherwise untapped, right? So these are very interesting and important use cases which are enabled by generative AI. So now let's talk through some of these use cases. So the first one, right, which is a content generation, there's a very large chip manufacturer based out of the Bay Area. They already use MySQL HeatWave for AutoML, for anomaly detection. And the use case they have is when they're generating or manufacturing chips, they test these chips, and the output of the test result goes into a log. There are millions of chips produced, and let's assume 1% of them have like a defect, right? So out of the million chips, let's assume 1,000 of them have some anomalies. What HeatWave already does for them is that they're able to very easily prune out the million chips, which are the 1,000 ones which they need to look at because of having very sophisticated anomaly detection techniques inside MySQL HeatWave. That's something they already do. However, until now, there would be a need for an operator or for a user to go through these 1,000 logs to figure out what's going on. With the combination of generative AI and AutoML, the user no longer needs to do that because the system is going to give you a summary like this. So now, sure, now the operator can look at the summary to say, hey, is it something which is really important or not? But you can see the amount of effort, the amount of time which has been reduced because the system is automatically not just generating anomalies or not only just flagging the anomalies, but also summarizing what that anomaly is. Right? So this is a very good use case of not just content generation, but a combination or the value which a combination of AutoML and generative AI provides, which is something which is a unique differentiator of MySQL HeatWave. The second example is we have a very large bank, one of the largest banks in the world. They're currently doing a POC with us where they're trying to detect for mule accounts. Right? And the basic idea is that they have a lot of like accounts in their database, and they're trying to see if there is any fraudulent activity going on. So we've been engaged in a POC using a HeatWave AutoML to figure out if we can identify those. With the combination of AutoML and generative AI, not only can we flag that there are some anomalous transactions, the system can also give a synopsis of what we believe the actual issue may be. Now again, then an operator needs to be involved to see that is it something which they want to flag as suspicious or not. But you can just see the output over here. And this is again running a combination of the LLMs which we support with HeatWave and the output which is being generated by AutoML. The third use case I want to talk about, right? So the first two were for content generation. Now this third use case is for RAG. One of a very large online food delivery company in EMEA, they use MySQL HeatWave and specifically AutoML for doing two things. One, predicting how long will it take for the food to be delivered, right? Because many times people just have a static SLA that, okay, for Domino's Pizza, it's going to be delivered in so many minutes. But in fact, often it is the case that the time it's going to take to deliver a food item depends upon the kind of food, because certain things take longer to cook. It depends upon the restaurant, because some restaurants are more punctual than the others. Third, it depends upon the distance or the time of day based on the traffic and such. So the first thing they're using HeatWave AutoML is to predict how long is it going to take to deliver some food item so that they can provide a custom SLA for each customer. That's the first thing. The second thing they're using HeatWave for is to make a recommendation. So if I know that, okay, this person has been ordering fast food like items, it would be in my interest to recommend to this user that, there's some sale going on, or there's this discount, or, this restaurant has come up, which offers good choices for some fast food items. So that's what they currently use HeatWave for. In fact, they migrated from AWS Aurora to HeatWave primarily because of its machine learning capabilities. So that's something they're already doing. Now what they're working with us is that, okay, we have this output from AutoML. We know the list of restaurants and the kind of food the user likes. We have LLMs which have been trained on the public content. These LLMs can look at the menu items of these restaurants and actually do something which is even more useful. What the system can now generate is not just the list of restaurants which may be of interest or the kind of items which may be of interest to the user. The system can actually generate that, okay, these are the menu items from these restaurants which we believe that the user is going to like. Right? So now you can say, hey, like recommend the 3 vegan dishes which have tofu, and the system will generate that, okay, these restaurants, these menu items, and there could be other factors involved. For instance, maybe the amount of calories, or the price range which the user has been ordering from. So what you can see over here is that the combination of machine learning which is inside HeatWave combined with generative AI makes for some very, very compelling enterprise use cases. And this is a differentiator. The second aspect or second advantage of having this combination is that if you take the output of AutoML, right, which is filtered and pruned, and feed it to the generative AI engine, it has 2 other benefits. One, the quality of the result will be better, right, because you're feeding it something which is much more specialized, and so the output quality is going to be better. Secondly, the performance is going to be better because the input is small and these LLMs, as you know, are expensive. So these are some of the techniques we use to make our in-HeatWave LLMs be more efficient. And then the last use case is that there is a very large government agency in the US, And they had this question for us that they have hundreds of thousands of documents over many years. And if their executive or if their domain expert, right, who's trained in a very different area, they want to query this data, they are unable to, because for any kind of query, they would need to ask a DBA to figure out what is the right kind of query to create, construct, what kind of indexes, what should be the schema design and such. But now, with the combination of vector store, which takes all of these documents, creates a vector store, and generative AI, they can now ask this question in English. So this is a prototype, but you can see on this real data set that they can ask a question, okay, which company won the contract for Dell laptops last year? Just imagine doing something like this on your own on unstructured data, right? So these are some examples which show the benefits of both generative AI and vector store for enterprise data. We are obviously going to support the capability where users can run the various generative AI models which are supported by OCI Generative AI. However, we are also providing a second option to our customers, which is we are going to run LLMs inside HeatWave. The benefits are it's going to be secure because the data never leaves HeatWave, right? You're doing your transaction processing, analytics, data lake, machine learning, generative AI. There is no need for the data to move, so it's going to be more secure. It's going to be much lower cost because you've already paid for this instance, you've already paid for the cluster, and we are running on the existing CPUs. And the third thing, and perhaps the most important thing, is guaranteed availability. Since you're not counting on some other service which is then counting on the availability of GPUs, which depends upon the region, right? You are guaranteed that you will get an answer. Now, it will not be as performant, right? Because it's running on CPUs instead of GPUs, but you are guaranteed that it's going to run. The other thing which we are doing to kind of improve the performance even on CPUs is that we are using smaller models, right? So we don't use the 70 billion or the 30 billion models. We're using the 7 billion models, which are smaller. And the second thing is we are doing a lot of research in quantization, so which is the right level of quantization to use so that we still get decent accuracy, right? So with these things, we are able to get decent performance, right? But the most important thing is guaranteed availability, security, and much lower cost. So this is a point which Wim also made, that one of the things we take pride in is that HeatWave is available in all regions, whether it's commercial regions, whether it's dedicated regions, whether it's government regions, and that will be the case for both generative AI and vector store capability as well. Now let's talk a little bit more about the vector support itself, right? So we are introducing a data type, a new data type called vector, which is going to be available in the community version or the open source version of MySQL. The processing of this will be available in the cloud in MySQL as well as in HeatWave. Now, HeatWave, one of the things which HeatWave does for MySQL is that it's a query accelerator. That's a case for vector processing as well. So you can surely process this vector data with MySQL. However, if you use HeatWave, it is going to be much faster. Now the question is, how much faster? Because we say faster, what does that mean? Well, HeatWave is an in-memory engine. What is the fastest processing anyone can do, right? Anytime you're doing data processing, you cannot do processing faster than the memory bandwidth. We do vector processing in HeatWave at memory bandwidth. Not just that, we do at memory bandwidth and we scale on more nodes. So if you're not satisfied with the memory bandwidth which you get on one machine, that's fine. You can just provision 2 machines, 3 machines, all the way up to 512 machines. So this is a very, very important point in terms of the implementation and the engineering work we have done with HeatWave. HeatWave processes or does a vector processing at near memory bandwidth, and it scales with the size of the cluster. The next aspect is the creation of the vector itself. So when you have some unstructured data, let's say a PDF, and you want to create a vector, there are 2 parts involved. One, you have to parse the data, and second, you have to create embeddings. Now, many times, people punt this responsibility to the user or to the application, saying, why don't you parse and create the encodings and then tell me, and I will do the vector processing, right? So many of the databases do that. Sure, that can be done. But if you do it inside the database, there are multiple advantages. One, the ease of use. The user just gives a document. They can point to the document in the object store, and the system does it, so that's ease of use. But the second aspect is the efficiency part. You have already paid for the cluster. We already have algorithms which we parallelize across nodes for query processing. We can extend the same benefit for vector ingestion as well. And parsing itself is not too expensive. However, embedding generation is very expensive. So we parallelize embedding generation across nodes. But performance aside, just the ease of use part, right? So if you have a repository of documents, and if you can just say, hey, load this data into HeatWave, and the system does it all for you, that's way more convenient than you as the application determining which parser to use for which file type, which embedded to use for which file type, and then when the time comes for query, you have to make sure that the two embeddings are matching. Because of that, we have built-in embedders inside HeatWave, which do this for you automatically. So just the way all these years you have been loading structured data or semi-structured data into MySQL HeatWave, we are extending exactly the same behavior for unstructured data as well. And for now, we are starting off with unstructured text data. The point of the slide is to show two things. A, we parallelize across documents, but we also parallelize within a document. So if you have a large PDF, we segment that PDF and we send these PDFs to different cores or different servers depending upon what's going to be optimal. That's the first part. The second part is the vector itself is being stored back to the object store. So one of the things to be aware of is with MySQL HeatWave, when we process any data from the object store, the data is never copied into the MySQL database. Right? Data in the object store remains in the object store. And that's true for vector as well, for unstructured data. So when we create this vector, we store it back to the object store. Many benefits of it. Object store, as I said, provides a least expensive form of storage. It's a most durable form of storage. It provides the ability to share across various tendencies and such. Right? And the vector contains not just the embeddings, but it also contains the text. Right? So the advantage is that when you want to query, you can just refer to the vector store and get all the information. You don't need to ever go back to the document. Well, only if you need document fidelity do you want to go back to the document, but otherwise for all query purposes, you can just access and be done with the vector store. So the creation of the vector store and the processing of the vector store, querying the vector store, they're all done in a massively parallel manner. These are some results just to show how good the scalability is. Now, once this vector has been created, this vector can be used in one of two ways. It can be used by SQL queries, right? So you can write SQL queries we're introducing distance functions, which I was saying process data, these queries at memory bandwidth. Or you can query this vector using natural language. And there are multiple ways in which you can query it in natural language. One is we're going to provide extensions to the SQL packages itself, like MLRAG, which you can provide the SQL input, or the natural language input. Or you can query it using the HeatWave chat, which is a UI which we have built where the user can ask these questions. So just to give an example as to how easy it is to use the vector store, you can create a vector store by calling HeatWave load, which is what you do both for structured data as well as semi-structured data. When you want to run a query, this is a standard SQL query, right? And you're just using a newly introduced distance function, which parallelizes very well. Or you can use MLRAG. You can invoke MLRAG where you can ask a question. So the same vector which you have created can be used both for SQL queries as well as if you want to query in natural language. This is an example of the syntax, just to show it's conforming to this. There isn't a standard per se, but what other databases are doing, and examples of some of the distance functions we support. This is the UI interface I was saying, a graphical interface we have for machine learning, which we are going to make available in short order. Now, just to kind of wrap up with the work which you've done in machine learning. So HeatWave machine learning is very popular already, not just because it's inside the database, not just because it parallelizes, but also because it's fully automated training. So all the aspects of training, like pre-processing, algorithm selection, feature selection, hyperparameter tuning, they are all automated. That's the reason people really like HeatWave AutoML, and a lot of the customers who are coming to HeatWave or coming to OCI are coming because of the machine learning capabilities of HeatWave. We have customers migrating from GCP to OCI because of these capabilities. And we are continuing to make them even better. So one of the things which our customers wanted was to see whenever there's a data drift, as your data is changing, customers want the ability where they can retrain their data so that now the model will be accurate corresponding to the new data which has evolved over time. We have added new sophisticated models for anomaly detection. We already had a homegrown model. We have augmented that. Plus, we are adding standard models like PCA. But the user doesn't need to worry about it because all of this thing is captured by AutoML. AutoML determines, based on the data the user has, which is the right algorithm to use. And then the last point over here was that we are taking these log anomaly detection techniques and extending them to MySQL logs. And that really has a lot of benefits in terms of diagnosability or in terms of the many use cases, because when MySQL runs across so many instances, we can use our own technology of anomaly detection to figure out if there was some issue in the service itself. So just to summarize, we have support for in-database vector store for being able to process unstructured text data. The in-database generative AI capability provides the power of LLMs to enterprise content. Vector processing in HeatWave can be combined with other SQL operators. So when you want to do vector processing, a distance function, it is not just limited to that. You can combine that with other operations, so you still have just a single database, but you have a single query which can collect aggregate data from multiple sources. We continue to augment our machine learning capabilities, both in terms of the quality of the results, classes of algorithms we support, classes of data sources we support. HeatWave provides the best performance in the industry, the best price performance in the industry, and the best scalability in the industry, both for data coming from the object store in a variety of file formats, as well as for data which is inside the MySQL database. And it's a single service for machine learning, generative AI, analytics, Lakehouse, and OLTP. Right? So it's a single database, provides you the best performance, the best price performance, and the best scalability. Thank you very much for your time.